The SS Badger is famous, but few people get to see how it actually works. Hidden below deck are the last operating Skinner Unaflow steam engines in the world. Hello, I'm Jason and you're watching Steam, Electricity, and Propulsion. In this video, we'll explore the engine room and figure out how it all works. Then in part 2, we'll head into the boiler room to see the coal-fired steam plant that powers it all. This ferry has twin 3,500 horsepower engines, which can run up to about 120 RPM. The boilers supply steam at 450 psi that's superheated at 700 degrees. These engines are among the most efficient reciprocating steam engines ever built. Part of that efficiency comes from the high pressure superheated steam supplied by the boilers, but another reason is the way the engines control power output. Instead of using a throttle alone, the Badger's engines can adjust the valve timing and steam cutoff. To adjust power output, valve timing is adjusted with these control levers. They operate hydraulic relays which admit lube oil into the pistons on the end of the camshaft. The timing chain drives these helical gears which change the angle of the cams relative to the crankshaft. In this drawing from Kevin, the retired chief engineer, you can see the camshafts, hydraulic pistons, and helical gears. Now you might wonder about how shifting cam timing adjusts cutoff. The reason is that the valve only opens when both cam surfaces act together. One cam can move the rocker arm by itself without opening the valve, but when both cams engage at the same time, the valve opens. In this animation, you can more clearly see the mechanism. Steam enters the high-pressure cylinder and then expands again in the larger low-pressure cylinder to extract more energy. The exhaust leaves through ports at the bottom of the cylinder, creating a one-way flow of steam that gives the Unaflow engine its name. Each engine has a condenser that turns exhaust steam back into water while also maintaining a vacuum on the engine exhaust. To condense the steam, large quantities of lake water are pumped through tubes inside the condenser shell. Most ships of this era use electric circulating pumps, but aboard the Badger, this circulating pump is driven by a Terry steam turbine. As steam passes around the tubes and condenses, this electric pump removes the condensate from the hot well. Because the engine cylinders are lubricated with oil, small amounts can enter the exhaust steam. These filters remove oil from the water so that it won't clog up the boilers. The filtered water then enters the deaerator where it is mixed with exhaust steam from the circulating pump turbines. This heats the water and removes dissolved air before it returns to the boilers. Below the deaerator are the feedwater pumps. While many steam plants use large multi-stage pumps, the Badger uses a coffin turbo pump. It has a single centrifugal impeller driven by a steam turbine that can reach speeds of about 9,000 RPM. This turbine is throttled based on water pressure. Right now, water pressure is set to 490 psi. The feed water pump turbine also exhausts into the deaerator. The boilers will turn this water into high pressure steam that powers everything from the propellers to the lights. We will explore the boiler room in the next video. The ship needs electricity not just for lights, but also for steering, lube oil, and even running water. In the back of the engine room, there are two 500 kilowatt generators. Currently, one is operating at not more than a 40% load. This gauge shows the ship's power consumption is barely 200 kilowatts. Unlike most ships of this era, which typically use 450 volt power systems, the Badger generates 240 volt alternating current. These generators are driven by steam turbines through reduction gears. The turbine operates at about 6,400 RPM, while the generator turns at 1,200 RPM, producing 60 Hz power from a 6-pole alternator. The turbine itself consists of a Curtis impulse stage followed by a multi-stage low-pressure turbine. After passing through the turbine, the steam exhausts into the condenser where a vacuum of about 28 inches of mercury is maintained. These gauges show the operating conditions, with more than 400 psi ahead of the nozzles and about 30 psi after the first stage impulse wheel. Oil pressure is needed for lubrication and regulating speed, and these gauges indicate the pressure. This is the governor. It uses centrifugal force to keep the generator's RPM steady to produce 60 cycles AC. Inside this housing are the fly balls and pilot valve. The pilot valve directs high pressure oil to a hydraulic piston, which rotates a series of cams that open or close the steam nozzle valves. Rather than throttling the steam, the governor opens the nozzle valves one at a time, keeping the steam pressure close to boiler pressure and improving efficiency. One of the cams also operates a compensation mechanism that works against the governor. This introduces a small amount of speed droop, allowing generator load to be shared properly when multiple generators are operating together. When speed fluctuates with changing load, operators must use this switch to correct frequency. The switch operates this small motor attached to the pilot valve linkage.
That just controls that little motor on the governor for the turbine. That's looking at generator number 1. Generator number 2 is offline.
One generator is currently running, but that synchroscope can be used to parallel them.
Alright, that's it.
Chief Andrew opens a watertight door near the stern of the ship, leading into the steering gear room. The steering gear takes rotation from the steering wheel and precisely moves the heavy rudder with the power of electricity. There are two motors and pumps for redundancy since the rudder is critical. The pump is a variable stroke machine which allows it to move any amount of oil in either direction. As the steering wheel turns, it moves a control linkage that changes the pump stroke. A feedback shaft connected to the rudder returns the pump to neutral once the desired rudder angle is reached. This electric gear pump supplies lubricating oil to the engine. There are two, one for each engine. This is a centrifuge which can be used to purify the engine oil. There are also control oil pumps for the camshaft hydraulic pistons. Passengers need water for drinking and sanitation. The smaller pumps pressurize water from Worthington for drinking only, while the larger ones pump lake water for toilets and sinks.
That's your lake water.
Here's a piece of machinery straight out of the 1900s. While most ships of the era use electric ballast pumps, the Badger uses a steam piston ballast pump. Each piston shifts the other piston's valve, which makes it so that only one can move at a time. The ballast pump can also serve as an emergency circulating pump for a condenser if one of the main pumps fails. Like the steering gear, many of the ship's auxiliary systems are duplicated to ensure reliability. To ensure reliability and safety, ships must have redundant auxiliary systems. There is also a crossover pipe that can allow one condensate pump to service two condensers if one fails. For feed water, there are 3 coffin turbo pumps, but only one was needed during the voyage. Lighting is critical for safety, so there is a DC emergency light system which operates constantly. In the engine room, 1 out of 2 25 horsepower motor generator units converts the ship's AC into 120 volt DC. This small diesel generator is located behind the bridge, which is high above the water and engine room. If the power went out, this control panel would automatically start the diesel engine to restore the emergency lights. There is also a gyro compass in this room for navigation. Installed in the 2000s for better safety, there is a 200 kilowatt AC diesel generator. This generator is powerful enough to completely restart the steam plant and steering gear in an emergency. While the large engine room is full of machinery, we have barely seen all the equipment required to make the steam. In the next video, we'll head into the boiler room to see the stokers, draft fans, and coal conveyors. I even learned how to rake ash, so you won't want to miss that. Lastly, I'd like to thank Chief Engineer Andrew and retired Chief Engineer Kevin. They provided the tour and helped me understand how the machinery works. I built this cardboard model of the Badger as a thank you gift for Chief Engineer Andrew.